Alright, so this is just, again, more practice problems to look at that are similar to what's on the homework and the quiz. So suppose that you have a nest egg of 670,000 with an APR of 4.25% compounded monthly. Find the following round of the penny. Alright, so we want to know the monthly yield for the annuity and the monthly perpetuity. Alright, so we have to do the perpetuity. So we'll do that second. Alright, so A first. So A is going to use the nest egg formula. But the one for the monthly annual yield, so the first one that's listed here. Alright, so we're going to use the monthly yield. And I'm not going to fill out the formula for you since I've done that a few times. The biggest thing with these formulas is just make sure where I've got parentheses, you also need parentheses. The only additional parentheses you might need is if R doesn't simplify. Alright, so our R, in this case, is 0.0425 over 12, which that doesn't simplify, so you will need an extra set of parentheses around the fraction. T is 12 times 20, so 240 months. Again, this would be the nest egg, how much is sitting in there. And so you plug it carefully into the formula, and make sure you try this on your own, because the biggest thing with this is being very careful. Added parentheses when I did the examples earlier, the same place I had parentheses earlier, you need them here. So the monthly yield comes out to be, so again, this would be the monthly income from your nest egg, would be $41,184.87. Alright, so that's A. B is a completely different problem. Alright, B is asking you, if I have my nest egg, alright, so this is how much you would take out every month if you're taking out both the interest and you're taking out some of the principal, which means at the end of 20 years, 0 will be left in the account. The other question is asking you, well, what if I just pull off the interest from my nest egg and I don't touch that money, so I've got the same amount of money in there every month? Alright, I leave the $670,000 alone, and I only take out the interest from that. Well, that yield you take your APR, divide by 12, so you take your R, and multiply it by your nest egg. Alright, you take your monthly interest rate, that's what this is, this would be the monthly interest rate, times the amount of money that's in there every month, because you don't touch the nest egg, you leave that same exact amount of money in there every month. So you get the same dollar amount out. Alright, and again, all you're doing is taking the interest. So basically you're spending the interest and leaving the principal alone. Right, so in this case, it's 0.0425 divided by 12 times our 670,000, and it comes out to be $2,372.92. So this is only interest, which means technically this account could last forever. Right? If you never, ever, ever touch the principal and only take out the interest, that money stays in there forever. Versus the first case, where you're taking out both the interest plus some of the principal, right? It's actually twice the amount almost. But you're slowly eating away at the nest egg. Right, at the end of 20 years, nothing will be left in there. A. B, you'll still have your money left in there. Alright, so that's the difference between those two. Alright, the next example. Suppose a person plans to retire with an account that earns 5.8 APR, compounded monthly. Complete the following sentences, round to the penny. Alright, so a nest egg needed in order to retire with a 25-year annuity that yields that amount. Alright, so I need to figure out my nest egg. So A, amount of money withdrawn, blah, 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 blah. Okay, so we'll do A first. First we have to figure out the size of the nest egg. So you're going to use the nest egg formula, but the second one. this one. We know how much we want to pull out every month, and we want to figure out, well, how big does it need to be in order to pull out $8,500 every month for 25 years. Alright, so the size of the nest egg is what we're looking for. We know our yield that we want. Our withdrawals is 8500. R is 0.058 divided by 12. And T comes out to be 12 times 25, which is 300. Alright, so you're going to pull out 300 of those. So those are the values you carefully plug into the formula. So you go in here and you carefully plug them into this formula. Where I have sets of parentheses, you need sets of parentheses. Alright, so make sure you're very, very careful when you plug it out. You don't need the one around the annuity. You need the one around the pluses and the minuses in the top and the bottom of the fraction. Alright, carefully plug it. Try it. Make sure you get to the same answer that I do. So the nest egg needed in order to pull out 8,005. It needs to be a pretty large nest egg. You're pulling out a lot of money every month. And so the nest egg needs to be $1,344,657.11. That's how large of money you need to have when you retire. Alright, so that's A. B, the amount of money withdrawn over the 25 years of the annuity. So B is how much money do you actually get out of this? It'll be more than the $1,300,000. Alright, you're going to pull out 300 times $8,500. Alright, so you're going to almost pull out twice as much. Comes out $2,550,000 total. Alright, so again, that extra comes from the interest, which is what we're going to figure out in part C. Interest. Alright, so how much you totally withdraw, which is the $2,550,000, minus how much you actually invested, which is the $1,344,000. Alright, then much in the nest egg, how much you withdraw with the next egg. The difference is the interest earned in your annuity, which again is quite a bit, because there's quite a bit of money in there. Alright, that's the interest. Alright, next example. At your child's birth, you begin to contribute monthly. And so this is an accumulation fund. This is the first case. Alright, you have an APR of 4.2 compounded monthly. You figure your child will need about $20,000 at the age of 18 to begin college. What does the monthly deposit require? Alright, so going to the formula sheet, that's this formula that you need to use, right? It's the accumulation fund, so it's not a retirement, right? So it has nothing to do with nest eggs. It's the, I have a goal, I have a time period to reach the goal, and I need to figure out, well, how much money do I have to invest every month in order to do that? Alright, and so it's the second formula there under the savings plan. Alright, so we want to figure out the monthly deposit. R is 0.042 divided by 12, and actually that one comes out fairly nice, 0, which is nice when we go to plug it in the formula. We don't need as many sets of parentheses. T is 12 times 18, so T is 216 months that they have to save. Alright, so you carefully plug it into the formula. Again, the formula for the monthly deposits needed. We have our goal, right? This is our goal, which would be the future value. And when you do, actually it's not a whole lot. It's just a little over $60 a month. Alright, so you have to put in $62.12 every month for 18 years to accumulate $20,000 if you can get 4.2% compounded monthly. Which, like I said, a lot of CDs right now, which CDs you can set up a time period for it to grow, you can get about 4% compounded interest. Alright, suppose that you're going to save to buy a car, and you plan to deposit $150 at the end of each month for 2 years. Alright, you can get 3.6 compounded monthly. What is the future value for the savings? Basically, how much money will you have to buy your car in 2 years. Alright, so we're looking for future value. We're making regular deposits. And so it's the other one. It's the very first one on this list, right? We're making regular deposits of $150. We want to find the balance in the future. So it's the very first equation on this list. Alright, we went to our deposits. Our 150. R is 0.036 divided by 12, which does come out nicely to 0.003. T is 2 times 12. So 24 months is how many times you're making your deposit of $150. Alright, so what's the future value? Again, you plug it into the formula carefully. That's, again, the balance at the future. Comes out to be $3,726.90. Enough for about a down payment on a car. Alright, you want to save $30,000 for a down payment on a home, making regular monthly deposits for 5 years. APR of 6%, how much money do you deposit each month? So again, you have a goal of $30,000. You're making regular monthly deposits, which is what we want to figure out. Your R is 0.06 divided by 12, which again, that comes out nicely. T is 12 times 5, so 60 months. So again, you want to figure out the deposit, so it's the second one listed here on the formula sheet. So we have a goal, we need to figure out the deposits, we have an APR, and a time period. Again, you carefully use the formula to figure out your monthly payments for those 60 months in order to reach your goal. Alright, so the monthly payments are $429.98 is the answer. Alright, so now we're going to do retirement stuff. As soon as we get to the retirement stuff, a lot of times this is going to be the nest egg. You plan to work for 40 years and then retire using a 25-year annuity. You want to arrange a retirement income, $4,000 per month. You have access to an account that pays 7.2% compounded annually. This requires a nest egg of. So again, we need to figure out the size of the nest egg. So they give us a lot of extra information there. All we're interested in is how big is the nest egg. So what you have to sort of break down is they gave us 2 different time periods, and you have to know which time period to use. For the nest egg, it's the retirement, alright? The retirement is what we're looking for. And so that's the time period. We actually don't need the 40 at all. They gave us that information. It was extra information. And more than likely, it's something that maybe if they had a part 2, you'd use it in the part 2 of the problem. How long would it take me, or what type of deposits would I need to get this nest egg? Alright, but that problem didn't ask that. It's just asking you for the nest egg. So again, nest egg means you're going to use one of the nest egg formulas. You want to figure out the nest egg. Your yield, right? Your income is the $4,000 a month. Your interest rate, 0.072 divided by 12, which again does come out nicely, 0.006. T is the 25. That's the tricky part of this problem. We only want to use the 25. We don't want to use the 40. The nest egg that you're going to live off of is set up for 25 years. Alright, so it's going to last for 25 years. Alright, so 25 times 12, so it's going to last for 300 months. Alright, so those are the values you're going to plug in to the nest egg formula. So again, you go to the formula sheet, and it's the one where we're looking for the nest egg, right? We have our yield, which is our $4,000. We have R, we have T. This is the one that's a little more complex. So again, extra sets of parentheses are always good in that case. So make sure you're careful when you're plugging it all in. What's nice about this one, though, at least R simplifies, so that makes it a little easier to type in. And so the answer is you need a nest egg, I can't spit it out, of a little over 500,000. Alright, you have a 20-year annuity with a present value of $575,000 if the APR is 6%. What is the monthly yield? All right, so this one's worded a little differently, and I believe there's ones that are worded kind of like this in your homework. And so this is how much you have now, right? Monthly yield is what you want to pull out of it. So this is a subtle way of saying this is your nest egg. All right, that's how much you have in your nest egg. You want to figure out, well, how much can I pull out for 20 years in this particular annuity? All right, so again, it's the subtle way of saying I have started with this amount when I retire, right? The present value is $575,000 when I retire. All right, for 20 years, I want to set up this annuity for 20 years. I want to pull out money. If I get 6% return on the money, how much money can I pull out every month for 20 years in order for it to last that long? Okay, so this one's a little trickier because it doesn't come out and say nest egg. Now, it does sort of give it away because the only formula with a yield is the monthly yield case. So it is the nest egg formula. So again, the present value is the nest egg, that $575,000. R is 0.06 divided by 12, which again is a nice one. T is our 12 times 20, which is 240 months, is how long we want to last. And so we want to figure out the yield. Alright, so we want to use this formula, because again, we're given the nest egg. Alright, so you carefully plug it in the formula. The monthly yield, so every month they can pull out $4,109.48 is the answer. Number 8. Alright, what size of nest egg? So that one's fairly clear. What size of nest egg do we need in order to retire 20 years? That yields $5,000 a month if I retire with an APR of 6%. Alright, so again, this one actually spells it out. Nest egg. R is that 0.06 divided by 12, so again that simplifies to the 0.005. T is 20 times 12, so that's the 240 months. We now know what our yield is, so it's the other formula. Alright, so it's the, what is our nest egg? Again, that's probably the more complex formula, so do make sure you really practice this one. Of all of them, this is the one that's a little trickier, as you do need the extra sets of parentheses. So do make sure you're careful and you practice this one on how to plug it in the calculator. So again, make sure you're careful. If you do, the nest egg, in this case, the nest egg needs to be 697,903.86. Is how big of, how much you need to have in order to retire with that goal in mind. Alright, the last one. Suppose you want to save $30,000 for down payment on a home, make regular monthly deposits over 4 years, your APR is 7%. How much money do you need to deposit? So this is, there's nothing, no nest egg, no retirement. This is the first case. This is the annuity, accumulation annuity, the first type. Alright, we have a goal, alright, which would be our future value is $30,000. We know our R is 0.07 divided by 12, and that one I have to leave exact. T is 12 times 4, so 48 months. Alright, we want to figure out that monthly deposit in order to save for our goal. Alright, so this is this one. Alright, we need to figure out how much we need to deposit to reach our future value goal. And we know R and we know T. Alright, so this is the formula we want to use. So we plug it in carefully. The answer is, if you plug it in carefully and do make sure you try it, $543.39. Alright, so like I said, the hardest part about these sometimes is figuring out what formula to use. You kind of look for your keywords. Alright, if I'm got a nest egg or a retirement plan, alright, then that's the nest egg case. If we're saving, alright, we're working and saving money and accumulating a large balance in the future, we have a goal in the future, then that's the first case. Alright, so we'll stop there. We're all done with 4.3.